Assalamu alaikum everyone. In today's lecture, we will be talking about, or we will start the discussion by some of the ways in which we can show the intersection count data, the turning movement count data, which we discussed in the last lecture. So one of the ways is to show it with this box diagram. So you can see there are boxes which are showing the numbers inside them. The numbers indicate the volume, and on each side you will see a number or a box which is showing the total volume. So this is the total volume here, this is the total volume here, okay. And then if the volume is outgoing, then the big box is connected with smaller boxes, each one showing a different movement. So this one shows right turn, this one shows true or straight, and this one shows left turning, and the number for each movement, the volume for each movement is given. Then we have arrowhead and tail diagram, which is this one. So you see there are numbers on arrowheads, numbers on arrow tails, and there are some numbers on the lines. Number on arrowhead means the volume is entering this road. So 6, 5, 6, 2 vehicles are entering this road. Number on the tail means they are leaving the road. So 8, 1, 3, 9 are leaving this road. And then the numbers on the line are showing the movement. So 1, 2, 5, 6 are taking the left turn from this direction. Now another important item about this arrowhead and tail diagram is the size of the arrowheads and tails is not random and it is not fixed. It should be scaled according to the volume, which they have done here. You can see the scale over here. So the arrowhead which is representing less volume would be smaller as compared to the arrowhead which is showing more volume. Okay, so this one is supposed to be smaller than this one. Then this is the representation they follow in the Ministry of Works in Bahrain. So you can see the highway names are mentioned here, okay, and some of the information about the study is given, the day and the date, the code, okay, the hours in which the study was done, and you can see different colors for each hour. And then again you see boxes, and the boxes are connected with arrows. Arrows are showing the movement, numbers inside the boxes are showing the volumes, and then you can see for each movement I have 3 different colors of boxes, or boxes with 3 different colors. So each color represents a different hour of the day. But as you can see here, there is no box which is showing the total. So you have to do the total yourself if you want to use this data. In the previous 2 representations, the total was given. Okay, moving on to a new topic, which is limited network study. What is a limited network study, or what is a limited network? First of all, it is a network of road which is affected by a major traffic generator. Now, what is a major traffic generator? A major traffic generator is any facility. It could be a compound, it could be a mall, it could be a housing project, but any facility which attracts a lot of traffic, that is known as major traffic generator. So University of Bahrain Sakhir campus is a major traffic generator. Bahrain International Airport is a major traffic generator. So the area which is around this facility will be a limited network for that facility. Now the problem with dealing with the network is that it has a lot of segments and a lot of intersections. So trying to cover all of them for the full period of the study is impossible. Why? Because you will need a lot of resources, and or you will need a lot of time. So in order to avoid that, because we cannot handle so much, we can do some sampling. So instead of taking from all locations and for the full period of the study, we take some samples. And obviously, you are not interested in the samples, you are interested in the actual count which you required in the first place. So on those samples, we have to do some calculations to get the actual count which we want for all locations and for the complete period of the study. When you are doing the sampling, you have to keep certain things in mind. The first thing is, when you have your network, identify the network, or identify within the network the portions. They are calling them as sub portions, meaning the parts of network which are similar to each other. Now they would be similar in terms of the type of highway, type of road, and they would be similar in terms of the type of area. Okay, they call it the land use. Okay, so any area which is existing in your network and it has similar type of highway, or it has a particular type of highway, so in that area that particular type of highway will become what portion of your network. okay, and in a different area the same type of highway will become another portion of your network. Now in each portion, in each sub-portion or portion, you will take two types of counts. We call them control counts and coverage counts. What is the difference between them? The difference between them is control count is taken for full period of study, while coverage count is only taken as a sample. So for example, if you are doing a study for 24 hours, a control count would be 24 hours. But the coverage count in the same area in the same time will be a sample of the 24 hours. Okay, could be any number of hours, but it will not be full, because if it is full, then we will call it a control count. Some things you have to keep in mind regarding these counts. First of all, the ratio of control to coverage should not exceed 20. So if you have 20 coverage locations in your area, in your sub portion of the network, then one control is enough for them. If more than 20, then you should have at least 2. It depends upon, but you have to maintain the ratio. The ratio should not go more than 20 in any case. If you have 50 coverage locations, then 1 will not do. Even 2 will not be enough. 2 control will not be enough. So you have to make 3 out of them. Okay. The control counts, as I mentioned, you are making sub portions in your network, right? So each sub portion is showing a different type of highway and different type of area. So area, as I mentioned earlier, they call it the land use. Land use can be commercial, residential, educational. So you may have a arterial in a commercial area. You may have a local street in a commercial area and a local street in a residential area. So for each combination, you should have at least one control, and the remaining in that portion will become the coverage. Okay, so for each sub portion, you will have one control, and sub portion means same type of highway, same type of area. All counts are taken at mid blocks. Call them segments, call them links, whatever. But the point is, no count is taken on intersections, because intersection counts are very difficult. They need more effort and more time and more resources. So no counts are taken at intersections in limited network study. And the other is also true, that no segment is left from your study. You have to cover all the segments. So the rule is no intersections and all segments must be covered. No intersection is covered, all segments are covered. Okay, now your client can ask you for intersection data, that I need the data for this intersection, that intersection. In that case, you will not do the study again. What you will do is, so intersection is made up of 3 or 4 different directions. So since you covered all the segments, so you already have the data for each direction from that segment. So you can combine all of them and you know the data for the intersection as well. Okay, so if you go by that rule that you cover all the intersection, then intersections, it will not be a problem. You will have some idea of the volume at the intersections as well. This is an example from the Isatown campus. Now we are not in Isatown, but the example is from Isatown for the time being. So this is our campus. You can see there's an educational area here. There's Isatown here, there's Zytown here, there's Ali here. So these are different types of areas. They differ in their characteristics. In each of these areas, there are some streets, local streets. Okay. So since areas are different, on each local street I should have at least one control in each of these areas. And then these areas have some highways as well. Okay. So these main highways, the Sheikh Salman Highway, 16 December Highway, okay, and the National Constitution, something like this highway. So these highways, the parts of these highways which are in a specific area will have their own control. And the other parts of the highway in the same area will have coverage. Okay. So for example, this highway goes from this education area up to some other area. So in education, the parts which are within the education area will have one control and the other coverage. And the parts which are in the other area will have again a separate control, and the others in the same area will become coverage. Same thing with the local streets. Okay, and again you have to maintain the ratio. So if there are 50 local streets here, one control will not be enough. One is minimum, but to maintain the ratio we have to make more than one. Okay, this is an example now where we have 7 points, 7 different segments. So it goes from 1 to 6, and then we have location A. So 1 to 6 are coverage, and A is a control. Okay, so as we said, the full time period of study is observed at the control at point A. On the others, we will spend some part of the time period. What is my time period? From 12 p.m. to 8 p.m. Okay, from 12 p.m. to 8 p.m. So they need data on all these locations from 12 to 8 p.m. Okay, now the consideration is how many teams I have for collecting data. They could be teams, they could be instruments, but they only have two. So at a time they can only collect data from two locations, not more than two. Now, one of these teams or instruments will be on location A, because on location A I have to take full data. So one team or one instrument cannot leave location A, otherwise the data will not be full. The other team has to finish the other 6 locations, the coverage locations, in the same time period. This is another rule. Okay, coverage locations must be covered, all of them, in the same time period when you were covering the control. Okay, when you are doing the control count, the coverage counts must have some parallel time period. Okay, so this is, so you have to cover, if you are spending 8 hours on location A, then in the same 8 hours you have to cover other 6 locations, and there's only one team. Okay, so what they did, they said, okay, on location we will fix one team on location A, they will do everything, all the hours on location A. So we have the control count here. On the other locations we only spend 1 hour, so other we have 6 locations. Okay, so to cover 6 locations I only need 6 hours. Okay, so problem solved. I can cover 6 locations in 6 hours. The rest of the 2 hours we can leave, no problem, we can take rest. So these are the counts. So now the remember what you are doing, find out 8-hour count for all locations. Okay, now for location A it's not a problem because I have the full 8 hours value, the values of all the 8 hours. Okay, so what I will do is I will just add them together. Okay, and I will have the total 8-hour volume at A, which is 7067. Okay, so this is for location A. Okay, location A, not a problem. Now for other locations I have only 1 hour of data, so I have to convert 1 hour to 8 hours. So for that we will calculate some factors which are known as expansion factors. Okay, the factors we are going to calculate are called as expansion factors. Let me put it over here. Okay, so I need, for every hour I need to calculate an expansion factor. Okay, so my hours are 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6, 6 to 7, 7 to 8. Okay, these are my timings. Now how would I calculate the expansion factor? Expansion factor is simply the proportion of traffic on the control count from the total. Okay, the total traffic on control count is 7067. So what proportion of traffic is coming in 12 to 1 hour? Okay, this is what we call as expansion factor. Okay, so now keep one thing in mind which we will use later on as well, that all factors are calculated using the control location. Whenever we are talking about a factor in limited network study, it will be calculated from the control count data. Okay, so 12 to 1 control count data is 825, the total is 7067, so it will be 0.12. 0.12 is my expansion factor. Okay, similarly then I will do it for the other location, for the other counts, other hours. Okay, so the location is same, control. Okay, so it will be, if you do 811 divided by 7067, 0.11. Okay, similarly we will do it for the other hours as well. Okay, these are the expansion factors. I use the same method to calculate them. Now I calculate expansion factors to calculate the 8-hour count. Now what do I have on the other locations? On the other locations, I have the hourly count and I want to convert it to total. Okay, these are proportion of the total, right? So you have the proportion and you have the count and you want the total. Okay, so if imagine if you had the total and you wanted the hourly count, you will multiply with the proportion, right? So now we are doing the reverse. You have the hourly count and you have the proportion, you're calculating total, so you will divide now. Okay, so expansion factors will be divided by the count of each hour. Now I'm using the coverage locations because I need the count for the coverage locations. So I will write location here, then I will write the 8-hour count for each location. Okay, so location 1 was taken between 12 to 1. So this is location 1, then 2, then 3. Sorry for that. 2, 3. 3 to 4, I don't have any data. See here, 3 to 4, there's no data. Okay, so I skipped this hour. Put 4 here, 5 here, and 6. Okay, so now what do I do? So I take count from location 1, which is 840. This is taken between 12 to 1. The factor for 12 to 1 is 0.12. So I divide by that and it will give me the total. Which is 7,000. Okay, in the same manner I will calculate for the others as well, because for each location you will take the count of that location and the factor of that hour. Okay, so for example location 2, the count is 625 and the hour is 1 to 2, so the factor of 1 to 2 is 0.11. 5, 6, 8, 2. Okay, I do it in the same manner for the rest of the locations. Okay, these are the counts. Now they are the 8-hour counts for the rest of the locations. Okay, now let's say I'm also interested in which one is the peak hour out of these 8 hours. Okay, so obviously the only way to find out that is using the control count, because only the control count has the full data of the 8 hours. Okay, the other locations have only 1 hour, so this is on location 1 only has data of this hour, so I don't know the peak hour for location 1 because I don't have other hours. If I look at the coverage control location A, then I can see in the entire 8 hours data, and I can see that 5 to 6 is the peak hour because it has the highest traffic. Now for the control, the problem is solved because I know the hour, the peak hour, and I know how much traffic is in the peak hour. For the rest of the locations, half of the problem is solved, because the rule is whatever happens on the control will happen on the coverage as well, because they are part of the same part of the network. They are in the same part of the network. Remember the sub portion, so they belong to the same sub portion. So if the peak hour is between 5 to 6 on control, then it is the same peak hour for the rest of the locations as well. So location 1, 2, 3, 4, 5, 6, all of them have the peak hour between 5 to 6. So half of the problem is solved. I know the peak hour is between 5 to 6. But what is the traffic in that peak hour? I don't know, except for location 5. And this is also by chance, because on location 5, by chance they took the data in the peak hour. So 1215 is the peak hour volume for location 5. Without any calculation, I know that because I have already identified the peak hour. Okay, but what about the rest of the location? Location 1, 2, 3, 4, and 6. How do I do that? Okay, now I have total. Remember, I've already calculated the total of the 8 hours. Okay, the peak hour carries 0.16 of the total. So I have the total and I know how much the peak hour carries of the total. Okay, so now I will multiply the expansion factor of the peak hour with the total. Okay, the same thing which I was doing, same concept I was using for calculating the total out of the hour Now I will use it in reverse to calculate the hour out of the total, but not any hour, the peak hour, which is 5 to 6. Okay, so I will take the total and I will multiply with the factor of the peak hour. Okay, so this one will be okay, so this is a peak hour volume on location 1, which would have come in between 5 to 6. Okay, for location 2 the total is 5682. And should I change the factor? No, because the peak hour is the same, the peak hour which has a factor of 0.16. So this is 909. Okay, in the same way you will take the total of each location and multiply with the factor of the peak hour, which will not change. Okay, so these are the peak hour values for each location. Okay, just to complete the solution, I have also written the value which is for location 5, which was already taken between 5 to 6 p.m. Okay, but just to complete the solution so that you have everything in one table here. Okay, so this is it. We will continue with the next example, so hopefully this will help you.